What's happening, y'all? Pastic here, and in this video we are going to find the equation for tangent lines for two specific functions, and this is basically going to be a little bit of practice finding derivatives of sinusoidal and polynomial type functions. So without further ado, let's find the derivative, or excuse me, the tangent line for g of theta equals 2 theta plus 3 cosine theta. So first thing we're going to do is find our point of tangency. If I plug it in the original function, so we're going to throw pi equal to theta. I'm going to do that real quick. Okay, so I've plugged in pi and I've gotten the output of 2 pi minus 3, as you can see. So that gives us a point of tangency of pi comma 2 pi minus 3. So now we have to find the derivative. So to find the derivative, g prime of theta, we're going to have to find it in two parts. So first we're going to find the derivative of 2 theta. So the exponent is 1. Bring down the exponent times the coefficient would be 2. The old exponent was 1, and now it's going to lower to 0. So the derivative of 2 theta is just 2. Plus 3 cosine of theta, and by now we should hopefully know the derivative of cosine is negative sine. So it's just going to be the derivative of cosine, which is negative sine, times 3, so minus 3 sine of theta. From here, what we need to do is plug in pi into the derivative in order to find the slope of the tangent line. So I'm going to do that real quick. And in order to do that, you need to remember that the sine of pi is 0. So we basically have 2 minus 3 times 0, which is 2 minus 0, which is 2. So now we've gotten both the point of tangency and we've gotten the slope of the tangent line. All we have to do now is use point slope form to come up with our tangent line equation. So I will do that real quick. So as you can see here, I've used the point slope form for the equation of a line. And I can now simplify that into different forms, but this is a totally acceptable answer. It just depends on what type of problem you're working on. If this is an open-ended, you can absolutely leave your answer like this. If this is a multiple choice, you might have to manipulate it to look like another possible answer. So I'm going to do that real quick. So as you can see, I've rewritten it by distributing the negative and the 2 on the left and the right, and then just combining like terms and moving things around, and you get y equals 2x minus 3. So pretty much the same thing on this one. Before we go anywhere, we have to plug in x equals 2. So h of 2, I'm going to do that right now. So as you can see, through a lot of algebraic manipulation, I found out that h of 2 is equal to root 2. And I've got a point of tangency of 2 comma root 2. So now the next thing we're going to do is find the derivative, but before I do that, I want to rewrite this as a polynomial. So let me do that real quick. Okay, so I've rewritten this as a polynomial, 2x over x to the 3 halves. Then you subtract the exponents, you got 1 minus 3 halves. You got 1 minus 3 halves, which is negative 1 half, so 2x to the negative 1 half power. Now we're going to find the derivative. So h prime of x equals, multiply the exponent times the coefficient. So negative 1 half times 2 would be negative 1, x to the negative 3 halves, which is the same thing as negative 1 over x to the 3 halves. And then we're going to plug in 2 to find our tangent line slope. And we're going to get negative 1 over 2 to the 3 halves, which is negative 1 over the square root of 8, which can then be rewritten as negative 1 over 2 root 2. And that is the slope of the tangent line. So now we just use that point slope formula again to take our point of tangency and our tangent line slope, and we make our tangent line equation. So I will do that. So as you can see, I've done that. The point slope equation looks like this. So this is our final answer. We could rewrite this again, but honestly, it would just be messy, so we're going to leave this one alone. But if you're curious about it, we can always talk about it. That's it for now. Hopefully you got something out of this. You can learn how to find the derivative of polynomial functions and sinusoidal functions and find their tangent line equations. I'll catch you next time, y'all.